dividing one polynomial by another. And so the first two is kind of introducing the topic. Number one, if we divide the polynomial p by the factor x minus c, and we obtain the equation p of x equals x minus c times q of x plus r of x, and we say that x minus c is the divisor, q of x is the quotient, and r of x is the remainder. Okay. Now, I want to point out that this is one of the forms that we have, but there's also this form here. Okay. So the divisor is x minus c in this case. But if you take this whole equation and divide everything by x minus c, then you're going to get p of x over x minus c equals, and this is your q of x, plus r of x over d. Okay, so that's how. So those are equivalent forms right there. Okay, let's go to part 2. If we divide the polynomial p of x by the factor x minus c, and we obtain a remainder of 0, then we know that c is a 0 of p. If we divide the polynomial p of x by the factor x minus c, and we obtain a remainder of k, then we know that p of c equals k. Okay, this right here is called the remainder theorem, and we will use this later. There'll be some exercises later on that specifically deal with that. So if you, again, basically, if you divide by x minus c, then the remainder is going to be, you're going to get a number for the remainder, and that number will be equal to p of c, as you just plug the value into the function. Okay, and the reason for that is from here. Okay, so if you want a justification, then you can go to here. If you plug in a cn for x there, you plug a cn for x right there, you get c minus c. And this is all going to be 0 because c minus c is 0, right? So you're just going to get this. Okay, so the p of c is going to be a remainder of c, which is going to be k. So that's the only thing is to justify that this is going to be just a number, which it's going to be when you divide by x minus c. Okay, number 3. Two polynomials p and d are given. Use either synthetic division or long division to divide p of x by d of x and express the quotient in this form. Okay, so here is p of x and here's d of x. So we're trying to find this right here. This one divided by this one. Okay, so what you do is you put the 5x minus 7 on the outside. What you're dividing by, you put on the outside. Then you put this on the inside. And in this case, there's none, the powers go down consecutively. So this is the x cubed, x squared. The next one is x. And the next one is without the factor. So 3, 2, 1, 0 right there. So you're fine there. Okay, so now what you do is you look for what number when you multiply 5x by that, or what expression when you multiply 5x by it gives you 10x cubed, and the answer is 2x squared. Okay, so you put that there. So 2x squared times 5x is 10x cubed. But you also multiply here, and that's minus 14x squared to keep these x squareds lined up. Okay, but that's important right there. Okay, now, right here, you have to remember to subtract this. Subtract that. Okay, so this minus that is 0. This minus that is x squared plus 14x. That's going to be 15x squared. Okay, minus 21x plus 9. We'll just bring those other things down. Okay, then you go to the next step, which is what times 5x is going to give 15x squared? And the answer is going to be 3x. Okay, so 3x times 5x is 15x squared. 3x times 7x is negative 7. I'm sorry, 3x times negative 7 is negative 21x. Okay, and then again, you're going to have to remember to subtract this one, which means that's going to be 0. That's also going to be 0, and you're just going to have a 9 coming down. Okay, now 9 is a lower order than 5x, because this is x to the first power, this is x to the 0. So you're done there. This right here is, this is your quotient. This is your, this is your quotient. Okay, so that goes here, 2x squared plus 3x. And this right here is your remainder. Okay, so that means you're going to write that as 9 divided by this. And that would be the answer. Okay, 2x squared plus 3x plus 9 over 5x minus 7. Okay, number 4. Two polynomials p and d are given. Use either synthetic or long division to divide p of x by q of x. Okay, so we're going to divide this one by this one and express it in this form. Okay. So again, we're going to, on the outside, we're going to put the divisor. And on the inside, we're going to put this one. Now here, there's a gap. It goes from 5 to 3. So we're going to leave a space there. Or if you want, you could write a 0x to the 4th. Or just leave a space. Either way. And then it goes down consecutively from there, so we're fine. We don't have to put any more spaces in. Okay, so again, right here, it's 2x cubed. 2x cubed times x squared is 2x to the 5th. 2x cubed times negative 3x is negative 6x to the 4th. 2x cubed times 1 is 2x cubed. And again, you have to remember to subtract. You got to remember to do that. So that's 0. This is going to be 0 minus a negative 6. That's positive 6x to the 4th. 1 minus 2 is negative 1. So that's negative x cubed. Then just bring these down. Like that. And then go to the next step. So this right here, it's going to be 6x squared. 6x squared times x squared is 6x to the 4th. This times this is minus 18x cubed. This times this is 6x squared. And again, remember to subtract right there. Got 0. This is going to be 17x cubed. This is going to be negative 8x squared. Okay, and we go to the next step. 17x times x squared is 17x cubed. Um, 17 times that is minus 51x squared, and then plus 17x. Wow. Okay, so subtract, that's 0. This is 43x squared. This one is minus 14x minus 8. And then finally, 43 times x squared is 43x squared. So And then 43 times 3, what? That's 129 minus 129x. And then plus 43. Okay, and then when you subtract this, you actually get positive 115x minus 51. Okay, so again, remember to subtract here and to subtract there. You got to remember to subtract all of these. Otherwise, if you forget just one of them, then you get it wrong. And then you have to figure out how it got wrong. Okay, so the answer, this is your q of x right here. And this is your r of x. Okay, so the answer is going to be 2x cubed plus 6x squared plus 17x plus 43 plus 115x minus 51 over x squared minus 3x plus 1. Make sure that's a -1. Okay, so that should work out for being the answer right there. Okay, any questions about anything so far? Okay, let's move along. Okay, so now we're going to express it in this other form. So we have this divided by that. Let's go ahead and do that over here. So this polynomial divided by that one. Let's do it in green. So this goes outside. And this one goes inside, so it's 25x to the 4th minus 9x to, this is x to the 5th. Oops. And then plus, there's no x cubed term, so I'm going to go 0x cubed plus 3x squared. There's no x term, so just 0x minus 3. Okay. Oh, this is a 27. Whoa. If that was a 25, then this would be a really nasty problem. Okay, so 9 times 3 is 27. And we're missing x cubed. Okay, so 9x cubed. So multiply that, that's going to give you 27x to the 5th. And then this times this is minus 27x to the 4th. And then this times this is 9x cubed. Okay, so now here we have to remember to subtract. That's 0. This is going to be 18, positive 18x to the 4th. And this is minus 9x cubed plus 3x squared minus 3. It's optional to write this, by the way. You can just leave it blank. But it's good to put a space there. Okay, next stage. 6 times 3 is 18, so that's 6, and then x squared. So multiply those together. Those two is minus 18x cubed. This times this is 6x squared. Okay, then subtract. This is going to give you positive 9x cubed minus 3x squared, and then minus a 3 over here. Okay, then let's see. 3 times 3 is 9, so that's going to be 3x. So multiplying there and multiplying here is going to be negative 9x squared, and then plus 3x. Okay, subtract. That's going to be 0. This is going to be 6x squared minus 3x minus 3. Okay, so remember, subtract there. And then 2 times 3 is 6, so that's going to be 2 as the last one right there. So multiplying 2 times 3x squared is 6x squared. 2 times 3x is negative 6x. 2 times 1 is 2. So subtract, that's 0, that's 3x, and this is minus 5. Okay, so writing it in this form, it's a little bit different than the other form. But here we have all the information. This is going to be our q of x. And this is r of x. So p of x is equal to the divisor, which is this one, times the q of x, which is that one, plus the remainder. Okay, that's going to be the answer right there. Okay, there's this one right here. But this one's slightly easier, so I'll go ahead and just do this one. So again, the inside is going to be what's on top. And outside, we have what's on the bottom. Okay, so this is going to be 3 times, because 3 times 3 is 9. And then this is x squared already, so it's just 9x squared. And this time this is minus 21x. Subtracting, and we get 20x, and this is plus 4. Okay, so again, reminder to subtract. And then this is a lower power than that, so we're done. We're done with that part of it. Okay, so this is the quotient. And the remainder is 20x plus 4. Is this right here? So those are the answers there. There's 2 ways that you can write this. Let me just kind of emphasize that. One way is you could, it's equal to, this is equal to this quotient plus the remainder over the divisor. Okay, that's one way you can write it, which is the p of x over d of x way. The other way is you can write it this way, which would be like this. Just taking this numerator, that's equal to this 3 times this divisor plus the quotient. Okay, that's just multiplying. So basically this way, or this one, is you just multiply each of these terms, each of these 3 terms, 1, 2, 3, multiply each of those by 3x squared minus 7x. This one, when you multiply by it, you just get this. This one, when you multiply by it, you get that. And that one, you just get the numerator. Okay, so that's 2 ways to express it right there. Okay, now next thing we're going to do is this thing called synthetic division. And the way that works, well, let me just, with this problem, I'll illustrate how you do it, how this works. I will do regular division, and then I'll do synthetic division to just give you an idea of how that works. Okay. Okay, so we're dividing, so it's x to the 4th minus x cubed plus x squared minus x plus 2. Okay, So this is regular division. I'm not doing the synthetic yet. So I guess I should, hold on. We'll do synthetic in red. If this is regular. This is regular. Okay, so this is or long division, or whatever you want to call it. Okay, so this is going to be x cubed here. Multiply those out. X to the fourth minus 2x cubed. Subtract. And that's going to be 0 there. That's going to be x cubed. Okay. Multiply here. No, I'm sorry. What am I thinking? Okay, so next thing is you just need an x squared. That's the next one. So multiply by, I'll bring these down. Okay, x squared times this is x cubed minus 2x squared. Okay, subtracting gives you, this makes it 3x squared. Okay, so the next one's going to be 3x. And multiplying, you get 3x squared and then minus 6x. Subtracting gives you, that's 0. This is 5x plus 2. And then the next one's going to be 5. Okay, so 5 times x is 5x. 5 times negative 2 is minus 10. Subtracting gives you 12. Okay, so by regular division, this is going to be the quotient. So regular division, this is going to be x cubed plus x squared plus 3x plus 5 plus this 12 over x minus 2. Okay, and so your quotient is going to be x cubed plus x squared plus 3x plus 2. No, plus 5. And your remainder is going to be 12. Okay, so those will be the answers to that. Those will be that's the answers that they're looking for right there. Yeah. Okay, now synthetic division. What happens there? Instead of having to remember to, like, here you have to subtract, there you have to subtract, here you have to subtract, you have to subtract. And then also you have to write all these x's out. So with synthetic division, it's a way of which you don't have to subtract, you just add, which is easier somehow. And you don't have to write any of the x's. So what you do is, if you're dividing by x minus 2, then you take 2, okay? So x minus 2, you set that equal to 0, that means x is going to be 2. So you put a 2 there. Okay, that's signifying that you're dividing by x minus 2. And then for these guys in the numerator, you put just the coefficients. So this means this is from x to the fourth. Okay, so x to the fourth minus x cubed plus x squared minus x plus 2. That gives you -1. That gives you positive 1. This gives you -1. This gives you 2. Okay. So first step is you bring this one down. Okay, this one is going to stand for x cubed. It stands for this piece right here. Multiply these two together, that's 2. Add those together, that gives you a 1. This is going to represent your x squared, or this x squared here. Okay, multiply those together, that's 2. Add those, that's 3. This represents 3x squared. That represents that one. Oh, wait, 3x. I'm sorry. 3x. Okay, multiply these together, that's 6. Add, that's 5. This represents plus 5. Multiply those together, that's 10. Add, that's 12. This 12 represents 12 over x minus 2. Okay, so that's how synthetic division works. So let's just do it on the next problem. We'll just go straight to the synthetic division. Now, one thing to remember. Okay, so with this problem, it's x minus 3, which means it's going to be a 3 right here. With this problem, what you have to remember is that there's no x squared term. It's basically 0x squared. And there's no x term, so that's basically 0x. And then there's a negative 27 there. Okay, so you have to account for all the terms. Otherwise, it will get out of sync. Okay, so bring the 1 down, multiply. Add, that's 3. Multiply, that's 9. Add, that's 9. Multiply, that's 27. That's going to be 0. Okay, so for this one, from here, that gives you x squared plus 3x plus 9. That's going to be the quotient. And the remainder is 0. Okay, number 9. Use synthetic division, the remainder term, to evaluate P of C. Now we talked about that on the first page briefly. And essentially what you do is you just run synthetic division with this one. Okay, so you have a 1/2 there. That's going to be what that's outside. Now, if it's saying to evaluate this, then you just put that value in. You don't make it negative like you would if you were dividing by x plus 1/2. If it's divided by x plus 1/2, then you would put a negative 1/2 right here. Okay, so then these are 4, and 7. Okay, so 4x squared plus 4x plus 7. Bring the 4 down, multiply, that's a 2. Add those together, that's 6. Multiply, that's 3. Add those, that's 10. Okay, and so your answer is going to be P of 1/2 equals 10 with a remainder. Okay, same thing with this one. We straight up put a negative 2 there. This is 5x to the 5th. There's no x to the 4th term, so you got to put a 0. 10x cubed, that's a 10. Squared, that's 0. And then x to the first power is 1, and then 1. Okay, bring the 5 down. Multiply, that's negative 10. Add. Multiply, that's 20. Add, that's 30. Multiply, that's negative 60. Add, that's negative 60 still. Multiply, this is getting out of hand. 2 times 60 is 120. Add, that's 121. Multiply these together, that's negative 242. Okay, adding that together gives you negative 241. That's the remainder. So P of negative 2 is negative 241. Okay. Technically, if you wanted to find P of negative 2, I mean, doing the straightforward way, you would just put a negative 2 into here, and here, and there, and it would be negative 241. Okay, so factor theorem. This is a new concept, I suppose, that we haven't talked about yet. Let me kind of just run through it, okay? So we have c equals 3, and we have this, right? So we want to show that x minus 3 is a factor. So in this case, it's going to be x minus 3, because c is 3, right? So we do synthetic division with a 3. And so 1, 2, negative 4, negative 33. Okay. So if you bring the 1 down, you get that. That's 3. Multiply, that's 3. Add those together, that's 5. 3 times 5 is 15. 15 minus 4 is 11. 3 times 11 is 33. Okay, this right here, when that adds up to 0, that means that it is a factor. Okay. When you get a 0 in there, that means it is a factor. Okay, the reason, if you do the other form, if you do this form right here, we just plug everything in. This polynomial what it's telling you is that's equal to x minus 3. That's the divisor was x minus 3, right? Times the quotient, which comes from here, x squared plus 5x plus 11, plus the remainder, which is 0. So that's basically plus 0. So essentially, we didn't really even need to write that. Okay, so that's telling you that this polynomial factors into this times this. In other words, this is a factor of this polynomial. Okay. Also, this is another factor, by the way. Okay, these are both factors because this times this is equal to the original polynomial. Okay, so that's number 11. Let's do number 12. Show that c equals 4 is a 0 of this. Okay, so remember, to being a 0, then you're going to get, if it's a 0, then the remainder is going to be 0. Okay, so that's all we have to show. That's basically showing that. So let's do it over here. So we have a 4 here. So this polynomial is 1, -4, -5, and 20. Okay, so 1, -4, -5, 20. Okay, bring the 1 down, multiply, that's 4. Add, that's 0. Oh, I love to see 0. 4 times 0 is 0. Adding, that gives you -5. 4 times -5 is -20, and boom, this is 0. Okay, so that means that c equals 4 is a 0. Okay, now it says find all other zeros of p of x. So what you do is you start from this, okay, which is x squared minus 5. You start from this. And you set that equal to 0. And this is a quadratic, so you're going to solve this. Okay, so x squared is 5. X equals plus, extracting square roots, you get plus or minus √5. So the answers are -√5 and √5. Those are the additional zeros right there. Okay, because what happens is that this polynomial is going to factor into x minus 4 times x squared minus 5. That's what the synthetic division is telling you. And then setting that equal to 0, you have 4 is going to be a 0 because, you know, when you put a 4 in, that's 0. But then plus or minus √5 are also going to be zeros. Okay, let's move on to the next exercise. Number 13. It's the same. It's more of the same. Let's see. Show that -2 and 1/3 are zeros of this. Okay, so I'm going to show that -2 is a 0 first. -3, -7, -37, -17, and 10. Okay, so bring a 3 down, multiply, that's -6. Ooh, add, that's -13. Okay, -2 times -13 is +26. Oh, adding here you get -11. -11 times -2 is +22. Adding you get +5. -2 times 5 is -10. Okay, so then boom, we get 0. So that's checking that off. Now, You could show 1/3 as a 0 by putting a 1/3 here and doing the same thing, but really what you should do with this one is do it right here. You already have the other factor right there, so you use the 1/3 there. So bring the 3 down, multiply, that's 1. Add those, that's negative 12. Multiply, that's going to give you negative 4. Adding those, you get negative 15. Multiplying, you get negative 5, and you got a 0 there. Okay, so that shows that the 1/3 is also a 0. Okay, now the biggest reason for doing this way, despite the fact that it's only 4 instead of like 5 across, is that now this right here is going to give you the other zeros. Okay, so the other zeros, you're going to use this right here. 3x squared minus 12x minus 15. Okay, so I can factor a 3 out, and that gives x squared minus 4x minus 5. And then I can factor this into minus 5 and plus 1. Okay, so this gives you negative 1, this gives you 5. So the other two zeros are 5 and negative 1. Oops. And negative 1. Okay, so those are the other two zeros. So all the zeros are negative 2, 1/3, 5, and negative 1. Okay, we can flip this around also, which is the number 14. Find a polynomial of degree 4 with these zeros right here. So you can just construct it this way. You want negative 4 to be a 0, then you make x plus 4 a factor. You want 0 to be a 0, you make x a factor. You want 4 to be a 0, you make x minus 4 a factor. And then x minus 6 a factor. Now, usually you want to put this in the front, so I want to put the x in the front. So you can expand it out if you want, but Webassign will just accept this as the answer. Okay, number 15. Find a polynomial of degree 4 with these zeros, and the coefficient of x cubed is 7. Ouch. Okay, so let me put the 0 for, let me put that one first, and then there's x plus 1, and then there's x minus 3. Now this one right here, this 1/3, the easiest thing to do for that one, because you could put x minus a 3rd, but then you have fractions. So the easiest thing though is 3x minus 1 will do it. And then put like a number, put a constant out here on the front, okay? Now you want the coefficient of x cubed to be 7. So we're gonna have to expand this out. Ouch. And to find out what value of a will make this coefficient 7, the coefficient of x cubed. So let's see here. Let's multiply these two together first. So this is 3x squared. Actually, you know what? Let's do this. Let's do this. We'll multiply these two together. That's x squared plus x. That's those two. And we'll multiply these two together. So that's 3x squared. Let's see, minus 9x, that's minus 10x. And then the last one is plus 3. Okay. Okay, now we'll multiply these together. So this times this is 3x to the 4th. Let's just do this x squared and everything. So minus 10x to the 3rd. And x squared and 3, that's plus 3x squared. Now this one, x times that is 3x cubed. This time this is minus 10x squared. This time this is plus 3x. Okay. So the leading term is 2x to the fourth. The x cubed terms are going to be those two. You have minus 7x cubed. The square terms is going to be minus 7x squared. And then the last term, 3x. Okay, now here, this is a coefficient of -7. You want it to be 7, though. You want it to be positive 7. So if you distribute this a in, if you distribute the a in, then this will be -7a x cubed. You want this coefficient to be 7, though. So a if you -1 works. So I'll make this a -1. So -1 times all that. So I'll put a -1 in there. If you distribute -1 in, you're going to get -3x to the fourth plus 7x cubed plus 7x squared minus 3x. Okay, just multiply each of these terms by -1, and that's what you get right there. That should do it. Okay, I think we have one more problem to go. Find a polynomial of degree 4 whose graph is shown. Okay, so what you want to do is you look at the zeros here, and this one, it kind of just goes straight through. So that means that x plus 3 is going to be a 0. Here, same thing. So x plus 3 is x plus 2. Because -3 is a 0, that means x plus 3 is going to be a factor. -2 is a 0, that means x plus 2 is going to be a factor. Here, it touches and goes back up. So that means x minus 1 squared, because that looks like a parabola right there. So x minus 1 squared will be a factor. Okay, so you could have a times x plus 3 times x plus 2 times x minus 1 squared. Okay, that's going to be your general form. And it's degree 4 because there's 1, 2, 3, 4. The power of x is going to be 4. The highest power of x is going to be 4. So we can decide what happens by this right here. Okay, this is telling you that p of 0 is 6. Okay, so we're going to set x equal to 0 here. So 0 is p of 0 is 6 is equal to a times 0 plus 3, 0 plus 2, 0 minus 1 squared. Okay, this is just 1, so it goes away. And this is 3 and 2, so that's going to be 6a. That means a is 1 works. And so if we just write down x plus 3, x plus 2, x minus 1 squared. You can expand it out if you want, but if you're lazy like me, you don't. They'll accept that answer.